aquifers and springs. It's going to give you a little preview into all the units we're going to be seeing this school year and in the exact order we're going to be seeing them in, and it's a good day. It's a good day. All right, so first thing I want you to do is I want you to tell me how many aquatic ecosystems can you name? How many can you name? And aquatic, so no prairies, no forests. All right, let me see. What are some of our responses? Ooh, Larissa, so smart. I see a lot of good answers. So I'm going to start going through some of these. Swamps, marshes, lakes, rivers, wetlands, ponds, rivers, underwater caves, ocean, ponds, lakes, oceans, rivers, seas, streams, geysers, swamps, bogs. Who said bog? Mia. You're so smart. All right. Wetlands, swamps, lakes, oceans, rivers, swamps, oceans, lakes, ponds, estuaries. Boom. All of it. Good job, y'all. Reese, coral reefs. Good job, Cameron. All right, and Melody. Okay, very smart. Very proud of y'all. This is good. Okay. Let's see. I do want to point out who said. I'm trying to find you, Mia. So swamps, bogs, and marshes are all examples of wetlands. So when we cover wetlands, we're going to talk about the difference between them, and then I'm going to tell you about bog bodies. Pretty cool. All right, it's kind of scary. So good job. So I want to also know now, what are the differences between them? Shauna, did you sign to go play in college? While people are typing their answers, I saw something on Twitter.
No. It was LSU.
Was it LSU Eunice?
Yeah. They might internet me because I was in the car.
That's exciting.
But yeah.
Keep me posted. I remember those days. Over a decade ago. All right, so what's the differences between the type of ecosystems that y'all listed? There are also examples listed here, but we covered almost all of them anyways. So let's see what we said. Some are covered in algae, yes. Some are inland and some are offland, yes. Different species, you have salt water, you have warm water, you have cold water. They are in different climates. Some are larger and longer than others. Different animals live there, salt versus fresh, plants and not. Boom, boom, boom. Temperatures looking beautiful. Great job, y'all. Y'all so smart. See, I told you it's my GT class. I don't have to worry about y'all. All right, so the difference is we listed a lot of great things. I'm going to move on to the next slide. I separate out these ecosystems into 3 different categories. So if you would like to write this down, please do so. Freshwater ecosystems include aquifers and springs. I guess I could have put aquifers / springs because they're connected to each other. But aquifers, springs, rivers and streams, lakes and ponds, freshwater ecosystems. We're going to talk about what's the difference between lentic and lotic ecosystems when we get to that unit. All right, so we're kind of, oh man, I had lots of words. We're kind of like putting aquifers, springs, rivers, and streams all in the same one, because aquifers and springs are really short. But the real meat and potatoes of this unit 3 will be rivers and streams, and we're going to talk about what lentic means. And then next unit will be ponds and lakes, and we'll talk about what lotic means. And after that, we're going to hit wetlands. We're going to talk about estuaries and bays. We had to skip that last year because of COVID, so we just kind of added it in added estuaries into wetlands and put bays into oceans. We're going to talk about oceans and weather. And somewhere in between, I think, ponds, lakes, wetlands is when we start talking about fish anatomy, shark dissections, and fish tanks. That's kind of how it splits up this year. All right, transitional ecosystems are the ones that are salt and freshwater mixed together. And so those include wetlands, estuaries, and bays. Wetlands is kind of that cushiony area between the water and the land that protects the inland areas. There are so many different, wetlands are the area that have the most aquatic life. That's where a lot of wetland species, either it be birds, reptiles, fish, they all go there to reproduce and get their lives going. Estuaries is where rivers meet the ocean. And then we all know what a bay is because we have Galveston Bay. And then saltwater ecosystems, that's oceans. We can talk about coral reefs. We're going to talk about different things found in the oceans, etc. All right. So we're going to talk about 6 different abiotic factors that affect ecosystems, and we're going to talk a little bit more about aquifers and springs. So that's the big gist of today. So the first abiotic factor we're going to talk about, or you should know what abiotic means by now. Abiotic, non-living, biotic, living, so abiotic, non-living. The first one we're going to talk about is salinity. So how much salt is found in the water? How salty is it? How salty is it not? Is it fresh water? Is it salt water? Is it supersaturated salt water like the Dead Sea? And anything that goes into the Dead Sea, well, it can't support life because it's too salty. But if you go to the Dead Sea, all you're going to do is float because there's so much salt in the water. It changes its density and it allows a lot of things to float on top of it. It's pretty cool. Never been there, but it'd be cool to go to. We do have a salt lake here in the United States called Salt Lake City, Utah. And it's very rare to find salt lakes. Most lakes and rivers and streams are freshwater. You do need to know how salt is formed. All right, we kind of moved the part of the lecture about what types of salt are formed to the oceans unit, which is about salt water. But you do need to know that salt is formed when rainwater dissolves rocks, or when you're up in the higher elevations, the water is more turbulent, it moves faster, and so it starts to erode the rocks away. That's why rocks are really smooth on riverbeds. And so it erodes the rocks away, and over time, with that erosion, it releases minerals, and then once those minerals will start moving along, especially by the time they get to the ocean, they form together and they make salts. So that's how salt water is made, from the erosion of rocks. Any questions thus far? All right, so move on. All right, so the second abiotic factor is water temperature. I want to know, why is the water warmer near the equator? Why is the water warmer near the equator? I see what Mia wrote earlier. I don't know what a bog is, but I know it's not the same as a swamp. I'll give you a preview, Mia. Swamps have trees. Marshes have grass. Bogs have moss. Bogs are only found in northern parts of the region, so you will not have them in Texas, but you'll see them around the Great Lakes and up north. We'll get to that. That's a fun unit. I like them all. All right, so let's see. Some of the answers, we have 12 out of 23 responses thus far. The sun hits the equator more because the Earth is hottest at the equator line. The equator's furthest from the north and south poles. The equator's hot. The center of the Earth is where the sun hits more. It gets more direct sunlight, more direct heat from the sun. Boom. Great answers. So I'm going to go on. All right, so the water temperature is another abiotic factor, and it's warmer at the equator because it gets more rays from the sun. You don't have to write that down if you know it because it's common sense, but do know that around the equator, it is warmer. You can see that here in this diagram. And that's because that part of the globe is round. That part sticks out further and it is closer to the sun, so therefore it gets more of the sun's rays. The poles are tilted off to the side and they're angling away or underneath where the sun would reach them. All right, the third abiotic factor still deals with sun, but it's not talking about temperature. It's talking about the availability of light. How much light is available in the ecosystem? It obviously decreases with an increase in water depth. All right, and then the further down you go, the less light you have, the less warmth you get from the sun. Therefore, the water is colder, and colder water sinks because it increases its density, causing it to sink below warm water. And we all know that ice floats because of the crystalline structure found in ice when it expands. All right, so availability of sunlight. In this picture here, this is from the Bering Sea. It's about 1,300 feet below the surface. And at this point, you can no longer see any light coming from the sun, and you have to use a spotlight to see the aquatic life there. When we get to the oceans unit, we're going to talk about the different levels of the ocean and what those terms are called based on the amount of light that's available. And we're going to talk about the adaptations of the animals that live in those regions. All right, move on. Number 4 is oxygen gas. All right, the fourth abiotic factor is oxygen gas. So my first question to you is, what do you think contains more oxygen? Fast-moving water or slow-moving water, and why? All right, 13 out of 23 responses. Let's see what we have. I see a lot of what could be good explanations, even though some of them are wrong, but I like your idea behind it. So I'm just going to do a tally on who said fast and slow, and then I'm going to go pick the one that has the correct why. So we have fast, slow, slow. I moved to fast, slow, fast, so we're tied 3 and 3. Someone says they don't know, which is fine. That's why you're here. Slow, fast, 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 fast. Okay. Fast because it could pick up oxygen with speed. Fast because water molecules are moving faster. No, oh no, that's not quite it. Fast. Let's see. I saw a good one. Fast. Yes, this is great. Great. What was it? Brianna? I think fast moving because the fast moving water mixes with the air. Perfect. That's exactly the answer. I'm going to move on to the next slide. Abiotic factor number 4, oxygen gas. You have in faster moving water, it has something called turbulence. The more turbulence it has, the quicker it's moving, which means it mixes in more oxygen from the atmosphere into the water. So that was a good job, Brianna. So faster moving water, more turbulence, more oxygen. Is able to mix the oxygen from the atmosphere into the water. The higher in elevation you go, like up in the mountains, they have a more rapid decline in elevation because of it's a mountain. So it starts up really high, and then down the mountainside, you're going from super high elevation to a low elevation. And with that, the water is moving faster, and therefore it rolls over rocks and whatnot, and it allows that turbulence to occur. It is rapidly moving up in the mountainous areas, you're going to have rapids. People go whitewater rafting on the rapids. And during that, you see the white caps in the water. That's how water is getting mixed in. Waterfalls do a great job of adding oxygen into the water. You can see here, this is the Pedernales Falls State Park in Austin, Texas. In Austin, Texas, we have, or in that region, there is the Edwards Plateau. And in that plateau region, like here where we are, we're pretty flat, low elevation. But once you get to the Edwards Plateau, you shoot up in elevation in respects to Texas. And that's when you get to like the hill country. That's, you know, San Antonio has more hills. San Marcos region has more hills, and you're able to have structures, natural structures like this that have a little more turbulence that allow oxygen to incorporate back into the water. The higher elevation we are, the more oxygen there is because of the more turbulence. Therefore, there's more oxygen available to plants and animals. The higher up you go, at the beginning of the streams and rivers, and then when you get closer to the coast, like here in Houston, there's a lot less oxygen available because it was already used up before it got to us. All right, number 5, nutrients. Our examples would be nitrates and phosphates. Nitrates is the final product of the nitrogen cycle. It goes from ammonia, nitrite to nitrate. Nitrate is a usable form of nitrogen. All right, so there's you need to have nutrients as an abiotic factor for an ecosystem. How much nutrients you have depends on how much you can sustain in that ecosystem. That's why wetlands, they're the last the last mainland ecosystem before you hit the ocean, and that area has a lot of nutrients that can support a whole bunch of life. Phosphates are another thing that you need. You need that for DNA and proteins, which all life needs. And you get these nutrients from the runoff from the land that occurs from the mountaintops all the way down to the oceans. This picture shows algae blooms off the Texas state coast in the Gulf of Mexico. You can see how runoff can bring an excess of nutrients. An excess of nutrients is called eutrophication. We've covered that before, eutrophication, and it causes algae blooms. If you look down here at the bottom side of the picture, there's a little cloudier part. There's some more like brownish water outside of the algae blooms. That is where all the erosion and debris comes from the Rio Grande watershed and dumps out into the Gulf of Mexico. All right, moving on. Next, abiotic factor, the last one, is turbidity. This is the cloudiness of the water, and it is caused by soil eroded from the land. Turbidity. All right, you can see low turbidity is clear water, high turbidity is murky water. All right, turbidity, cloudiness, murky. We have high turbidity here in our part of the Gulf of Mexico. That's because of the Mississippi watershed and river, and that brings all the erosion from all, like half of the states in the United States down through the Mississippi out to the Gulf. And then because of the Gulf Stream current, we get the dirty side and Florida gets the pretty side. It's not fair. It's not going to change because the rotation of the earth determines the currents, so can't change it. All right, there is a video link on here. I'm going to show you the video. All right, so turbidity is the last abiotic factor. That's the cloudiness. Obviously, you're going to have animals here that are able to survive in turbid water, can see food, have adaptations to find food and to survive, versus other animals that don't have that ability, won't be able to survive in turbid water. I'm going to show you a video. It's called The Confluence of the Mississippi River and the St. Croix River at Prescott, Wisconsin. So this is where the Mississippi River meets the St. Croix River. And my question to you, what you will hold your answer for, is which side of this river or where it meets is the Mississippi. I'm going to show you. Okay, so after showing you that short little clip, I want you to answer in this chat box. after watching that video, which one do you think was a Mississippi River? The turbid one on the left or the clear one on the right? I would prefer if you use terms like turbid or clear. All right, champ, use your vocabulary terms. He likes it. All right, we have 9 out of 23 responses. Larissa, you're so smart. And so it looks like without doing a poll and counting, almost all of us said it is the turbid one, the one on the left. And I'm going to read what Larissa wrote. Turbid one because of your comment on how it is gathering a bunch of runoff from different states. We talked about the EPA controlling pollution and stuff because it's connected to from all these different states. So yes, it would be the one on the left, the turbid one, because the Mississippi River is a huge watershed and it collects a lot of runoff and erosion from other areas of the United States. Good job. All right, so we're done talking about your abiotic factors. We're going to have a short little kind of like mini review embedded in here over stuff you've already learned. And then we're going to talk about the difference between aquifers and springs. This is kind of like a different section within the notes, aquifers and springs. And I'm going to do a little mini review. Look how clear that water is, so pretty. When I went to the Frio River, the water was so clear, it was crazy. You could see the fish. Beautiful. Oh, okay, so I'm talking about the difference between aquifers and springs first. Aquifers, if you already know this because you already wrote it down, cool, don't have to write it down again. All right, aquifers are underground layers of permeable material. We talked about how it was gravel, sand, silt, and other rock materials. So underground layers of permeable material that collect, hold, and conduct water. This is underground region that holds water. This is why you're doing a porosity versus permeability lab. If you watch my video, the best example would be like gravel or marbles. It's a whole bunch of different materials. But if you pour water in it, it can hold water. And if you like put a straw in there, you can pump the water out. So it's an area that holds water, but it's not, I don't want you to think it's like a big swimming pool underwater. It's like filled with rocks. All right, and then a spring is where that water flows up from the Earth's surface out of that aquifer. If we look at this Texas state map, it's color-coded with the different aquifers. All right, and then most of our springs are located in the same general region. This area is that Edwards Plateau that I've mentioned about several times. This is where the elevation changes rapidly and you get into the hill country. Because of this change in elevation, there's different openings and cracks within the land throughout the hill country region, and that allows for springs to release or aquifers to release water into a spring. Water bottle companies get a lot of their water from these natural springs because it is clean, pure, fresh water that comes out of the ground. You might think water that comes out of the ground would be dirty, but it's not. Right? Soil has muddy water, but not aquifers. All right, and so a lot of this clusters around the Edwards Plateau region. This is where like San Marcos and stuff is. This is where all that river tubing happens because of that nice water. And then we have some that fall around other different aquifers around the state of Texas. You have your Ogallala one up here. All right, so move on. Question. Based on something we talked about, I think it was Wednesday, when you had to do your little pie graphs. How much of our water usage comes from aquifers, aka groundwater? How much of our water usage comes from aquifers, aka groundwater? Let's see, they're kind of all over the place. I see some of us clustering in one region. 13 out of 23 responses. I appreciate y'all that appreciate my paired X. All right, so move on. Give you the answer. The answer is 60%. 60% of the water we use in the state of Texas comes from groundwater or aquifers. And then 40% comes from surface water. That's because like where that Edwards Plateau region is, it separates Texas up into different sections. And we know that West Texas uses groundwater and East Texas uses surface water. And more people live in the western side, center side of Texas than they do on the east side. All right, next question. Out of that aquifer groundwater usage, how much of it is used for irrigation or agriculture? So out of that groundwater aquifer, that water that we use, what percentage is used for agriculture or irrigation? Ooh, we're all over the place. I see like 3 people that have the right answer. I'm gonna go ahead and reveal the answer. The answer is 80%. Out of the groundwater we pull, 80% of that is used for agriculture. I had asked you all the other day, do you think all states use most of it for agriculture? We said no, because not all states grow crops or have like animals that they raise for food. It was 80% agriculture, 15% for cities or municipalities, and 5% for factories, industries. All right, so another question for you. So Texas uses most of its irrigation water from the Ogallala Aquifer, but why don't they use the Gulf Coast Aquifer? And now instead of looking at where the aquifer is in the state, we're kind of incorporating the whole entire aquifer. All right, so the Gulf Coast Aquifer goes from Brownsville all the way over to Florida. So why wouldn't they use the Gulf Coast Aquifer? And why, like, instead of the Ogallala Aquifer? There's several answers. There's one best answer. I we're at 4 responses out of 23. Looks like some of us have paid attention to our Ed Puzzle videos. All right, so some things I'm seeing here that are correct. It's near the ocean, and salt can get mixed into the aquifer. Salt water can seep into the groundwater from the Gulf of Mexico. That is called saltwater intrusion. So we don't really use as much of the Gulf Coast aquifers. One, because of the chance of saltwater intrusion. We already are close to sea level. If we overpump, we're going to cause a lot of subsidence and flooding. And when we overpump, it's going to fill with salt water. The other reason is because we don't rely much on groundwater out here, so we don't really pump from it because we don't need to. And a third one, which is mostly not thought of, is elevation. The Ogallala Aquifer is at a higher elevation than the Gulf Coast Aquifer, so it's a lot easier to pump water out somewhere at high elevation and allow it to naturally flow down the elevation landscape to irrigate crops versus trying to pump that water upwards against gravity. All right, some good answers there. All right, so now we're going to talk about different characteristics of aquifers and springs. All right, different characteristics of aquifers and springs. All right, so these are the 2 slides I was talking about, short and sweet, and then I'm going to show you a 2-minute video, and then you're going to go on about your life. Aquifers are dark. They're completely underground. They're dark. They're nutrient poor. They don't get the nutrients from runoff because it's underground. And they have a low amount of oxygen because it's underground, and it doesn't have a chance to mix in with the atmosphere. So dark, nutrient poor, so no sunlight, no nutrients, no oxygen, or low oxygen. So those are 3 out of the 6 abiotic factors that you would need that we talked about earlier. So dark, nutrient poor, low oxygen. And so the only types of organisms that can live here are microorganisms. that can live in these kind of conditions. So you're not going to see like plants and animals, but you'll see tiny microorganisms that you might be able to find in the water. But that's about it. Any questions about that? Anyone still writing? Okay, give me a second. The characteristics for one more time. Low sunlight, low nutrients, low oxygen. Only things that can live here are microorganisms. Are we good now? Almost. Okay. Got a head shake from one and no from the other. Benefits of having your camera on, I can get some feedback from you. All right, how about now? Good? Okay, awesome. So aquifers, dark, nutrient poor, low oxygen, only have microorganisms. But when we move on to springs, springs are above ground. They have a constant temperature. They have a stable water quality, and they're disconnected from other water systems because they pull their water from underground aquifers. So I'm going to explain these. Constant temperature, it's not super cold, it's able to support life. Stable water quality. They get their water from aquifers, and so they're able to get that nice, clean, pure, fresh water from the ground. And they don't have to worry about getting water supplied from rivers and streams that are coming all the way from Canada, picking up debris from all around the place, or Colorado, all types of places. So they're able to stay pure and clean and support a lot of life. We have pictures of these salamanders off to the right. It looks like they're just living their salamander life. They're actually underwater. And so you can't even see the water because the water is so clear and so pretty. That's how it shows how it has good water quality here. Like I said, it supports a lot of common plant and animal species. However, in spring regions, they're going to have a lot of animals that are only found in that spring, which is why they are named after that area, that region. So San Marcos salamanders are only going to be found in San Marcos, Texas. You're not going to find them in Colorado. You're not going to find them in Florida because they are native and they have adapted to that spring in that aquifer's water. Then you have Barton Springs salamander, and then it says Georgetown salamander. Mine's covered up by my screen. And so they are going to support a unique amount of life that is specific to that area. All right. Good temperature, good water, disconnected from other things, less likely to have pollution, except for when humans come visit and pollute it. All right, move on. All right, so I'm going to show you a quick video, and then when I'm done with the video, you're going to go to the hub, and you're going to do Karst Cave readings. It's short and sweet, things like 4 or 5 questions embedded into an article, but I'm going to show you this short and sweet video, and then you will be free to go work on your assignments. Okay, hold on.
Have you
Oh, now
ever
it's
seen a naturally occurring spring where water is flowing out of the ground like magic? Where does that water come from? Well, it comes from an underground reservoir where the water can be contained in natural porous rock or sand, or even a complex network of underground caverns and cracks. These underground places are called aquifers. You see, when it rains, these aquifers gradually fill with water. Some even become pressurized. And some aquifers give rise to springs, a place where underground water emerges through ground faults and cracks leading to the Earth's surface. Here, a unique aquatic ecosystem can be created, providing life to a whole host of rare invertebrates, fish, and amphibians. Texas has more than 3,000 springs, some of which are among the largest in the world. And springs also create the headwaters for many of our rivers. Aquifers are an important source of water for humans, supplying about 60% of the water we use. And no matter where you are in Texas, you're likely standing over an aquifer, possibly hundreds or even thousands of feet below. Because aquifers are deep underground, most contain little or no large animals and no plants, but major springs in Texas can be teeming with life. Some even contain species found nowhere else. For example, Barton Springs, located in Austin, is the only place where the Barton Springs and Austin blind salamanders live. And Texas wild rice, along with the San Marcos gambusia, can only be found in the San Marcos Springs and river community just downstream. In fact, you can get your own close-up look at how a natural spring functions by riding in the glass-bottom boat at San Marcos Springs. Like most important natural features in our state, aquifers and springs are at risk from human intervention, contaminants from pollution, overuse by agriculture, and our own neglect to conserve water, not to mention the weather threat of long droughts in Texas that have already caused many of our springs to stop flowing. We just need to be water wise. You can think of groundwater in an aquifer as money in your bank account. Each time you put money in, the amount of money you have grows. When you take money out, your bank account goes down and stays down until you put more money in. Aquifers grow when nature puts water in through rainfall, snow, and other precipitation. By protecting our springs, rivers, and streams, we help aquifers continue to store water for generations to come.